Entropy. What is entropy? Entropy controls how a decision tree decides to split the data. It actually affects how a decision tree draws its boundaries. Entropy helps us to build an appropriate decision tree for selecting the best splitter. Entropy can be defined as a measure of the purity of the sub-split. Entropy always lies between 0 to 1. 0 indicates less impurity, and 1 indicates high impurity. The algorithm calculates the entropy of each feature after every split, and as the splitting continues on, it selects the best feature, and starts splitting according to it. The reason entropy is used in the decision tree is because the ultimate goal in the decision tree is to group similar data groups into similar classes, i.e. to tidy the data. Entropy formula. Consider a dataset with n classes. The entropy may be calculated using the formula below. Pi is the probability of randomly selecting an example in class I. Understand entropy. Let us see the above image, where we have the initial dataset, and we are required to apply a decision tree algorithm in order to group together the similar data points in one category. After the decision split, as we can clearly see, most of the red circles fall under one class, while most of the blue crosses fall under another class. Hence a decision was to classify the attributes that could be based on various factors. Example. Let's have an example to better our understanding of entropy and its calculation. Let's have a dataset made up of 3 colors, red, purple, and yellow. If we have 1 red, 3 purple, and 4 yellow observations in our set, our equation becomes where PR, PP and PY are the probabilities of choosing a red, purple and yellow example respectively. We have PR equals 1/8 because only 1/8 of the dataset represents red. 3/8 of the dataset is purple, hence PP equals 3/8. Finally, PY equals 4/8 since half the dataset is yellow. As such, we can represent PY as PY equals 1/2. Our equation now becomes, our entropy would be 1.41. You might wonder, what happens when all observations belong to the same class? In such a case, the entropy will always be 0. Such a dataset has no impurity. This implies that such a dataset would not be useful for learning. However, if we have a dataset with, say, 2 classes, half made up of yellow, and the other half being purple, the entropy will be 1. This kind of dataset is good for learning.
If you have any doubts regarding this topic, please comment down below. I will respond as per my best. Signing out.